Hello, everyone. So, in the previous class, we were talking about calculus, and I have explained the concept of calculus. The term means dividing your into small pieces, stones, small stones, because it's a Latin word. Okay, and what I termed is like say calculus to calculate something. Okay, and what we are calculating is in two ways, like one is differentiation, one is integration. So that stones, small stones that I told, very small fraction of data, we can do two things with that. That means dividing a huge data into small fractions, that is differentiation. And again, integrating, that means combining all these small fraction of data to make the same function again. That is integration. So we can differentiate also and we can integrate also. And it is used for like in significance as slope. Okay, that is one of the application to calculate the slope. And in data science and machine learning, calculus do have so many use cases. We apply the concept of differentiation measure in ऑप्टिमाइजिंग अ प्रॉब्लम दैट आई विल बीन टॉकिंग अहेड. आज मैं आपको थोड़ा सा उस बार आई विल टॉक अबाउट इट, बता दूंगा आपको. ठीक है. तो जस्ट लाइक आई वांट टू हैव अ क्विक recap. We are having a function. Okay. And the shape isn't important. It could be anything. कोई ज़रूरी नहीं है. The shape of a function can be anything. So we are having f of x. तो f of x को we do say y, और x आपका यहाँ पर है. ठीक है. This is your x. So we can say like that, x comma y. Okay, or I would say x comma f of x. And if we do talk about a first point or a coordinate, so I can say x1 comma fx1. That is what we can write. Fine. So another point can be like x2 fx2. Okay, so I am having two coordinate, 2 points. Okay. अब क्या करा था हमने, what we want to do, ये देखिए. In the previous class also I told, if I take 2 points very closer to each other. Okay, if I take 2 points which are close to each other, like suppose this is x1, this is x2, and fx1 fx2. So a coordinate, this is also a coordinate which is closer to each other, both are closer to each other. Fine. Now in this particular case, as you can see, we are calculating the difference of x2 and x1. We are calculating the difference of fx2 minus fx1. That means y2 minus y1. That's what we are calculating. So ultimately, this is also, this is a change. Okay, this is a change. Let me, okay, add. Fine. So this is a change, x2 minus x1. It's a change, and y2 minus 1, y1 is also a change. Okay. So we are trying to calculate change, rate of change, actually rate. Okay, if one term is changing, how it is impacting on another term. So I can take a ratio of these two. Here it is, ratio, ratio of these two. And for example, in a practical point of view, if you can see, let us suppose this is a ladder. Okay, this is a ladder, and this is a wall. Okay, ladder is kept against like this wall. And if you move a ladder in this direction, obviously This change is also expected. Okay, later will come down. So coming down, that means obviously this is y and this is x. So what can happen if I can give small change in x, let us call as delta x. There will be small change in y that we call as a delta y. So just considering del y by del x, that means I am expecting the rate of change in y with respect to x. If I change x, then what is the rate of change in y? That's what we are doing. That's the differentiation. Okay, so it's a like we are using it for many terms. Okay, so very practical phenomena, and it tells about many things. Okay, so yes, fine. You can have an equation of a line in this way also. M equal to y2 minus y1 upon x2 minus x1. I can cross multiply. So y2 equal to m into, sorry, y2 m into x2 minus x1 plus y1. This is also we can get. It's a equation. Okay, fine. So if this is the case, like here, okay, we are representing this line by this particular equation. Okay, and this line can be graphed using these two coordinates. That's what we have made. We call it as a secant line in the graph. It intersects the graph at exactly these 2 points. This is a secant line. If I make a line which do pass through these 2 points, it's called as a secant line. Okay, fine. Now let's see. So all these concepts are correlated, and I already mentioned about delta. Delta is a small change, a very small change. Okay, very small change. And this delta, small change, we already study in limits. Okay, we do study this thing in a limits. Fine. So very small change in x. Similarly, we can have a very small change in y, delta x and delta y. That is the rate of change. Okay, and that's what we called as a differentiation. And if we write like this is my point x1. This is a small change in x1. Okay, so I can write, okay, the slope is like this. Fine, the slope is given like this, and x1 and x1 will be subtracted. Then I will be only having delta x, and later on you can apply the concept of limits here. Limit delta x tends to 0, and whatever be the functions you are available here, here just put them. Okay, just put them. Fine, and then later on, once it is solved, put the value of limit. That's it. Okay, fine. So yeah, f of x minus fx1 mx minus x1. This is again a line. This is the equation of a line. Okay, fine. So that line is called as a secant. Okay. Limit concept I already told just right now. You can put a limit. Limit delta x tends to 0. Okay, fine. So in this way also, we can calculate the derivative of x f of x at x1 by using limits also. Okay. Um, See, for example, if you are having a function x square, want to find the derivative of f of x, and we know that what its derivative will be x square, the derivative will be 2x. You're trying to find that x equal to 2. Okay, so your x1, the point will be 2. So put it here in the limit formula. Okay, so f of x1 plus delta x minus f of x2 divided by delta x. Okay, the function is x square. X square. This is the function. So put this value into x square. So 2 plus delta x ka whole square minus 2 ka square 4 divided by delta x. and open this a plus b ka whole square. Okay, and after that this 4 and 4 will get cancelled, so delta x will be taken common, delta x will be cancelled. Okay, ultimately you will here delta x cancelled, so ultimately you are getting the answer as 4. Okay, because if you put the limit delta x tends to 0, here the answer will be 4. What is 4? What is 4? So that's the derivative of x square at x equal to 2. That's the value of the derivative at x equal to 2. Okay, fine. In this manner also we can do. Okay. Now these are the formulas. Okay, limit formulas. Okay, that's what we have seen just now. Okay, all these limits. Okay. Now the next term is very much important. That is minima and maxima. Okay, let me share my entire screen. Okay, and we discuss more on it, because we should know why we are learning these concepts. What's the requirement? In data science and machine learning, what you are having, what you do have, we are available with data. Okay, we do put the data in the algorithms. Algorithms are mathematical equation. Okay, fine, that's what we do. Ultimately, because you are working on AI, you're feeding data into an algorithm, into a model, you will get some result. Okay, you will get some result. Now you compare this result with actual, and if there is a difference you call it as error. Here here from here the concept, the application of calculus starts. What I need to do is I need to reduce error. I need to reduce error. The question is how, and how calculus is applicable in reducing the error. Okay, because we are training our model, we're building our model, we are getting a result, we expect that the result which our model gave should be likely to be equal like actual. If there's a error, a huge amount of error, then you are not, your model training is not going good. Okay, there is an issue. Okay, fine. So that's a problem. So we want our model to give good result. Fine. So क्या करें हम, what to do, how calculus is applicable here? If I would say E is the error, and the parameter which we are considering in the equation is, let us suppose, W. I will differentiate error. That means I will find the rate of change of error with respect to weight. That means one of the parameter present in the equation. That's what I will do. Rate of change of error with respect to weight. Why I will do this thing? Why? Again, the question is why? Why you will do? What's the matter? What's the reason? See, because because you are modifying weight. You are modifying weight. For example, now again check. If you do have y equal to x square, you perform dy by dx. That is 2x. That is the rate of change of y with respect to x. Okay. That means you're saying that if I will change x, how much impact it will put on y? That's the question. How much impact it will put on y if I change x? If I'm changing one quantity, how much it reflects to another quantity? That is what we are looking forward for in calculus. So in a equation, in this equation, what we have, y and x. Similarly, we will be having an equation like this: w dash is equal to w minus alpha del L by del W. This will be the equation which you are having in deep learning. In machine learning also, in linear regression, we'll be doing that. We're having such kind of equations. And there the role, the requirement is to update W. I need to change this W. W is my parameter. For example, if I would say in your linear regression equation, that is y equal to mx plus c, there m and c are the parameters. M and C are the parameters. X is your input, Y is the output. So input and output are already available in the data. X is there, Y is there. What is the scope? What is the next scope? What you can do next? If I would say I need to train my model, what is this training is? Training is all about adjusting the parameters. That's what I call as a training. बाकी X तो पहले से ही पता है. I'm already available with X. I'm already available with the Y. What next I'm going to do? What is called as a training? Training is adjustment of M and C parameters. So if the parameters got adjusted, I need to find the reflection. I need to find the reflection. That means if I change these parameters, I will get some value of y, new y. Whether this value, if I do compare with the initial value, actual value, that will be called as an error. So the point is, if I change the value of one parameter, it's reflecting on another parameter. The goal in AI is to reduce the error. So what sort of change I should bring in W or any of the parameter so that it will reduce the error? What sort of change I can give it so it will reduce? So जब ये rate of change आ गया, when the rate of change has been introduced, because change is introduced, we're changing the parameter. That's what we call it as a learning, that's what we call it as a training. So I need to take care of this thing, and obviously calculus is required, differentiation is required, and this overall is called as optimization. It's called as optimization. And we say that error should be less. That means I will try to change the value of my parameters, and it should be in such a way that the error should be reduced. That's what the optimization is. Okay, and this de by dw, because I'm going to put the minus sign outside, that's what it called as a gradient descent. Descent means error should have to be down, go down. That is gradient descent. Okay, ultimately I am going to look for minima. I want to minimize the error. That means I'm going to search for minima, not maxima, minima. And the concept of maxima minima we have studied in our 12th standards for the Indian, okay, schooling. That's what I studied in calculus. The concept of maxima minima says that, for example, you are available with a function or y. This is equal to like 3x cube. So we differentiate. Okay, we differentiate y. That means we do the first dy by dx. Okay, that's what we do, and then we equate it to x. That's what we do. For example, my equation is 3x cube minus 2x minus 2x. Okay, 3x cube minus 2x. For example, this is my function. So differentiation of it is 3 will come forward, 9x square minus This will be the differentiation. Okay, so what we have to consider here is the first differentiation dy by dx is equated to 0. Okay, the first differentiation is equated to 0. And the values of x are calculated. That means it is 9x square equal to 2, x square equal to 2 by 9. Let me consider it as 4. So the things will become easy. 4 by 9. And x square equal to 4 by 9, that means x equal to square root of 4 by 9, that is equal to plus minus 3 2 by 9. You very well know square root, sorry, that will be plus minus 2 by 3, because square root will give both plus minus. So it will be x equal to plus 2 by 3 and minus 2 by 3. It can be both. So you are getting two values. Now again you have to perform the double differentiation. Okay, double differentiation. All right. So y double dash. So that will be put to here 18x, and whatever be the values you have obtained in the first differentiation, put it inside in y double dash in place of x. Now, if double differentiation is greater than 0, so there will be minima at that particular point. If double differentiation is less than 0, then there will be maxima at that particular point. So we are looking forward for the maximum and minimum value of a function. Okay, where it could have a minima, where it could have a maxima. That's what we are looking. Okay, got it. So function, it's kind of a behavior. Okay, function. That's what I told now. It can have an any shape. It can have any shape function. So here you can see the function is increasing, then it is going to decrease. Okay, so for example, you are here. You are here at this particular point. So whether at this particular point, what's the behavior of a function? Maximum, whether it is giving maximum value, whether it is giving a minimum value. That's what you have to find. Differentiate. Whatever be the equation of the function, okay, differentiate, double differentiate, and find whether it's maxima, whether it is minima. And as why I'm considering this maxima minima, because I just gave you an example of error. I need to reduce the error. Reduction of error means, okay, I will be taking the gradient del E by del W. That's what I need to do. Okay, and this gradient, I'll put the minus sign, descent. That means I need to go down to reach the minima. Okay, to reduce the error. Ultimately, what should be the value of my W so that E will be reduced? That's what I want. So this is the application of differentiation. Okay, let's talk more about it. What is present in my notes, because I was explaining on my way. Global minima, global maxima. Okay, minima maxima. That means a real value function f defined on a domain x has a global or absolute maxima at a point this if function is greater than equal to f of x for all x in x. See, there are maxima and minimum. Global. Global means the max of the max value. Max of the max. Okay, don't go with this definition because I also don't understand too much English. Max of the max. Okay, and min of the min. Min of the min. That is global minima. This is global maxima. This is global minima. Now, sir, kindly show it on the graph like this. Okay, don't refer. Let me show you here. Okay, okay, here. Now, this is also maxima. This is also maxima, but this is global maxima. Okay, this is global maxima. Okay, fine. This is also minima. This is also minima. Minima, minima, global minima. Okay, this is global minima. Okay, that is minimum of all and maximum of all. That's what we call as a minima and maximum. So function to which we are taking a derivative, and double derivative is a function of the predicted line or error. Uh, Predicted line. See, line is what? What we are saying in form of a line. Okay, what we have learned na in our school days is, sir, this is a curve, and sir, let us suppose this is a line. Wherever the line cuts this particular curve na, so this line is called as a slope. That's what Abhay is saying. This is called as a slope. Okay, the line cutting the curve slope, and at this particular point where it is cutting, just calculate dy by dx. I hope that's what his question is. Okay, that's what his question. All right, and here differentiation dy by dx, that means you have to consider what? 2 points, y2 and y1, and x2 and x1. That's what you have to consider. 2 points, like small, very small, just like this, very small. These 2 points you have to consider. Okay, x1, x2, and yeah, x1, x2, and here it will be y1 and dy2. Okay, x1, x2, y1, y2. I can extend it here. Let me extend. Okay, so till here is x1, till here is x2, till here is y1, and till here is y2. Okay, so that will be dy by dx. So that's what we have learned, that make a curve and touch a line, and a point at which it is touched, that is the slope. Okay, and if I would say here that these are the global minima and the maxima, you can see global minima and the maxima, and check what my plots are here. Okay, this is global minima, that is minimum of all. This is local minima, this is local minima. Local. There could be many minimas, there could be many maximas, but they are local. The global is the maximum of all. See, this is also maximum, this is also maximum, but local. Okay, these are also local maxima. This is minima, this is minima, local. This is minimum of all, global minima. इससे नीचे नहीं हो सकता अब. I can't go below more than the global. I found the minimum of all. I can't go beyond. I got it. Okay, so now here is a theory, as the name suggests, and this suggests, and that suggests. I am not interested in talking about the theory. Okay, and the one question which came, sir, again, that's what I told now. That here it is x naught, y naught. Okay, because slope is also called as tan theta, and tan theta is perpendicular upon base. And here in my diagram also you can see perpendicular upon base, which I just made. Okay, if I say this is angle theta, so obviously this angle is also theta, corresponding angles na. So theta, so tan theta is perpendicular upon base, that's it. Okay, fine. That's what they are taking. Dy by dx is tan theta. The derivative function at a point x naught is equal to the slope of the tangent. Okay, slope of the tangent. Okay, again it will give you the rate of change only, so differentiation is rate of change only. Okay, fine. Now here it is. Now there is one issue. There is an issue. Critical points. What are critical points? For example, angle is 0, tan 0, sin theta upon cos theta. uh, Tan 0, I think tan 0, sin 0 upon cos 0. What is cos 0? Cos 0 1, sin 0 0. Answer is 0. Okay, that means differentiation is 0. That means you are not having any angle. You are having a flat line like this. So tangent is parallel to the horizontal axis. Then only the slope is 0. Regardless of whether the point is local, global, whatever, your differentiation is 0. These points are called as critical points. These points are called as critical points where the differentiation or the slope is 0. Okay, so we know that these critical points, there will be either local or global maximum minima. I don't know, whatever it may be. There could be anything. So these are called as critical points. Okay, so now here you can see the example. All right, few more things. So differentiating between maxima and the minima. See, here it is. You can make a curve like this. Minus ax square. Its differentiation is minus 2ax. And this is how you are going to make from positive to negative. Okay, this is minima. And this is how you are going to make from negative to positive. Answer is 2ax. Because your function is ax square and this is minus ax square. Okay, fine. Then here double dash is negative. That's what I told. If the double differentiation is negative, then I told you double differentiation is negative, then less than 0. Okay, then max. And if double differentiation is greater than 0, then min. Remember, minimum. That I initially talked about this concept. What double differentiation is. Okay, so double derivative. This is double derivative test to find maxima and the minima. So if there are multiple minima, calculate y values and check which is the lowest that point of the global minima. uh, up, there could be many minimas and many maxima. That's I already told. Many are there. So you, if you are available with a value, okay, like this. This is your function y equal to x cube power 4 plus x cube minus 6x square. Y dash is, this is the first differentiation. This is the second differentiation. Okay, and then what you have to do it at x equal to 0, x equal to minus 2.5, x equal to 1.4. These are found to be as a critical points. Why these are critical points? Because at these particular points I don't have any like maxima or minima. I don't have, it can be anything. I'm not sure about it. Because because if I put 0, if I put 0, because y dash is 0 at these 3 points. These are the critical points. All right. So what you have to do is, okay, one is 0, one is minus 2.5, one is 1.4. Okay, let us suppose this is 0, this is minus 2.15, and this is 1.4. Okay, and here is your curve is curve is made. For example, here is how your curve is made. Okay, at these 3 points the differentiation is 0. Okay, so if I need to calculate the slope, whether here it is maxima or minima, how the sign is changing, that's the question. How the sign is changing? If I go from here like this is also a slope. Okay, this is also a slope. Fine, this is also a slope, this is also a slope. Okay, so we do have the slopes. We do have the slopes. The point is, you have to check from positive to negative you are moving, or your negative to positive you are moving. That's what you have to check, from where you are moving. Okay, so we got the critical points. These are the critical points: x naught, x1, x2. We took we took double differentiation. We took double differentiation, and we put those critical points. I got minus 12. This is negative. So if double differentiation is negative, less than 0, that means maxima. You can see at this particular point 0, I have a maxima. At this particular point, I do have a maxima. You can see it's on a top. I do have a maxima at this particular point because it's minus 12. I do have maxima at this particular. However, it may be local क्योंकि अभी इससे और बड़ा भी है. ये होगा global, but it is local. I do have a maxima, or it's local. Okay. Then ये क्या है 30.57. If I put minus 2.15, this is positive. Positive means minima. So ये यहाँ पर minima है. I do have a minima here. Okay, I am at a minimum position. Minima है वो. Okay, fine. And then 1.4, that is again positive. तो यहाँ पर भी minima है 19.92. Again positive value, minima. So here it is, minima. Okay. For example, if you are getting positive value, minima. ये भी लोकल है, ये भी लोकल है. दिस इज ओके लोकल. हाँ, दिस इज लोकल मैक्सिमा, दिस इज ग्लोबल मिनिमा. Why global minima? Because no one is less than this. This is global minima, and this is local minima because it is above the global. They local. So we do have the critical points over which we calculate. Okay, like this. Okay, understand. Very good representation. Understand what's happening. This is local minima. Okay, what it is trying to show. This is negative. Step right. Then this is local minima. Okay, imagine the ball is rolling down the hill. Okay, imagine ball is rolling down the hill. It came down, 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 and it's stuck here. Here it's local minima. Then positive equal to what? Positive equal to step left. Positive means step left. That means again you have to go down to find the minima. Okay, it came to be positive, go down. This is negative, step right. If there is a negative value, step right. Continue. If the differentiation is negative, we will say that step right. Continue. That's why no one is going to tell you about this equation again. Let me refer you. Okay, d that's what I gave now. W dash is equal to W minus alpha del L by del W. Why I put minus sign? If derivative, okay, we just want it to be decent. We want it to go down. That means in opposite direction. Okay, and let's and what's happening in this particular diagram? Check. Okay, this is negative. Step right means proceed. This is here. It's local minima. Then find if the ball is present here. Again, take the derivative. Then it says step left. Okay, because minima. I need to reach to the minima. So step left. Okay. So right and left where you have to move. So this animation represents local minima and global minima. Okay, the gradient at different points are found. Okay, you can take the gradients. Okay, take gradient here, here, here. Find the gradient here. Find the gradients. Different points. Gradient is calculated. So it is required to move to left or to reduce the weight. Okay, it is to reduce the weight. Na? W dash is equal to W minus alpha del L by del W. Reduce weight. Optimize. Now, if the gradient value is negative at a point, it will be required to increment the value of weight. If the gradient is negative, okay, if the gradient is negative, then increment the weight. And about two steps are done until the minima is reached. Okay, we have to reach the minima. Minima could be either local minima or global minima, depends. There are different techniques to look out for that. There are different techniques to check out whether it can be local, whether it can be a global. Okay, so again, understand the phenomena. And there is one more issue that is called as point of inflation. point of inflation where I don't have any minima or either maxima. I don't have. Okay, it may happen that like this. You are having a slope and then like this. How can I find the slope here? How can I find the slope of a straight line? Slope can be find out for curve, not for a straight line. This is point of inflation. This region to this region is point of inflation. Yeah, INFLEXION, inflation. Because you can see slopes is all zero on these particular points. I'm unable to see the minimum, maximum, what it is. Point of inflation. Okay, and what it is trying to make you understand by this representation for maxima and the minima, it's saying that, and this concept is like rolling of a ball from a hill only. ऐसे ही समझाया जाता है. This is how it's been taught. I'll be teaching you in machine learning ahead like this only. I am available with a ball here. It will go down, then down, then again here. It may reach here again. If it will go down here, then here, then here, then it will reach here, here, then it will try to go upwards. And if I'm getting the global minima, it will stick here, then it will not progress. So at every point I need to find the differentiation, and very smartly move that showed in the representation. What smart move? That means if the gradient is negative, proceed. If the gradient is negative, proceed. वो कह रहा बढ़ते चले जाओ. और जब पॉजिटिव आ गया, दैट मीन्स if the gradient is positive, वो कह रहा है कि अपने डायरेक्शन चेंज करो. We don't want this thing, because my concept is gradient descent. बोले डिसेंट है, कम करना भाई, बढ़ाना थोड़ा. आई डोंट वांट टू इंक्रीज इट, आई वांट टू रिड्यूस इट. डिसेंट है. तो व्हेन द ग्रेडियंट केम टू बी पॉजिटिव, उसने बोला वापस जाओ, चेंज द डायरेक्शन. सो नेगेटिव साइन इज स्पेसिफिकली व्हाट आई से इज द डायरेक्शन. क्योंकि ग्रेडियंट पॉजिटिव होता है, मतलब ऐसा इधर, एंड डिसेंट इज नेगेटिव. रिवर्स कर दो, माइनस साइन लगा के पलटा दो उसे, एंड सी द रिप्रेजेंटेशन. See, when it was going down, nothing was there. It's when there is a positive step, then उसने direction change करा, again go down and reach to the minimum. Such kind of things happens in maths internally. All right, fine. That's what the concept I want to tell you about minima maxima related to calculus, especially differentiation. There are some things related to integration also, but not that much, because differentiation plays a major role. Rest I will share these notes to you. You can read. We have studied most of the concepts here. Okay, not much left with us now. Rest of these thing, when I will be talking about the algorithms now, there I will cover again this maxima, minima, and optimization and differentiation we have to do. That's the math we have to do. Every algorithm we have to mathematically derive. So that's what we are going to do it. All right, okay. So I hope you understood in this particular lecture also. Let me stop